Hello, greetings to lecturers and examiners. Today, I would like to present my FYP titled Optimization of Copper Removal from Aqueous Solution using Jatropha Oil-Based Membrane with Graphene Oxide via Response Surface Methodology. My name is Umar bin Majid with metric number 190223 for program Bachelor of Chemical Engineering. Next up are the legends, the abbreviation that I will use in this presentation. So introduction first up, the introduction to my product, to my project. Jatropha curcus is a plant from Euphorbiaceae family, and also it's native to the Central America. The potential of this plant to be based for many purposes due to its chemical stability to produce new compound, and in addition to that, its sustainability and eco-friendly to the environment. Common approach in using inorganic sources can be changed by implementing biodegradable and fully sustainable material. Abdelgadir and Van Steden, 2013, stated that Jatropha curcus also has gained an attention in other various industry as replacement to its fossil fuel application. So in this project, we are trying to tackle some of the problem, mainly the global resources depletion, and also to test the reliability and the performance of Jatropha with mixture of graphene oxide with 0.5 weight percentage for membrane filtration application. Next, the objective of this project is to screen the preliminary factors of heavy metal rejection, which are acidity, pressure, and concentration. Next is we want to find the optimal condition for copper rejection filtration using RSM, and also after the optimum condition was achieved, the data was tested with actual application of heavy metal rejection. So the literature review that simply that I could say that from academia, so that say that materials from hydrogenated vegetable oil have been spotlight for synthesis polyurethanes, and also Nyamplung seed oil-based polyethylene membrane have been used to remove heavy metal from removal from water. So this is our overview of our methodology, starting with synthesis and then application, experimental design, and then characterization of solution. First off, the epoxidation. We have the synthesis, epoxidation, reopening process, and polyaddition. Epoxidation, where we mix acetic acid, amberlite, and CgO, and then we heat it up simply, and then ring opening process, where we open up the bond and add hydroxyl with water, sulfuric acid, methanol, and with an epoxy, the epoxide EGO. And then to produce polyurethane, we add 5:5 ratio of graphene oxide, HDI, and then after it become Vaseline-like structure, and then we cast it on glass stationary dish, and then this is our membrane filtration application. Starting number one with reservoir tank, and then go to plastic pump, pressure gauge, and then into the chamber itself, and then we control the pressure of the chamber with the control valve, and the pressure and the pump was set at 40 rpm. So for experimental design, we use one factor at a time to find the design range, and also we use a response of RSM to find the optimum condition, where we use CCD for computer design, and also fast-centered due to limitation runs, where we could reduce the amount of center points for the experimental design. Next up is the result and discussion. This is for offered experimental result. Based on the offered experimental design, the rejection has no increment between 140 and 160 ppm. where it's constant at 67 rejection, but the maximum rejection is at 100 ppm with 73 rejection. In addition to that, when pressure and acidity were tested, the same condition shows the optimal condition where at 100 ppm concentration, 1.5 bar pressure with pH 5. However, the acidity factors only affect the rejection in a decrement of 1% at pH 5. So we believe that the acidity factors does not affect much to the rejection of heavy metal. Then next, this is the design of RSM that have been designed by RSM, and the yellow highlighted box, the experimental data that were done. Next, this is the fit summary table that will show the suggested model for the RSM. So the yellow highlighted box denote the suggested model according to the value of coefficient of correlation or R squared and adjusted R squared and predicted R squared. So this value coefficient of correlation shows the model ability to predict an outcome close to the actual outcome. So in this we are in this run of RSM, we suggested linear and also quadratic model. So this is our run of linear model. This is the result of ANOVA analysis. This ANOVA analysis linear model, where the factors are tested independently without taking taking in the interaction between the factors. So the factors are tested, analyzed independently. Hence, the result is similar to OFAC, where the acidity factors is insignificant to the rejection of copper. Next, this is the quadratic model for our model for ANOVA analysis result. Linear model, from this result, the interacting factors that are insignificant to the design are only AC and BC. So because the main ABC factors are the main factors, but the interacting factors is AC, BC, AC and BC, but we can see that only AC and BC are insignificant. So I can conclude that the factors acidity, factor C, are insignificant. So which factors that are interacting with acidity factors will also be insignificant. However, based on the predictor R value, which is negative 0.1643, where we want to achieve higher than 0.9, so we have do the reduction model was used. So this is the result. The reduction models was used because the insignificant interacting factors was removed, and based on this model we can see that all the R squared, adjusted R squared and predicted R squared, we have obtained higher than 0.9. This is the normal probability and the predicted versus actual graph from the reduced quadratic model. And also this is the three-dimensional surface and contour of interaction. So we only have one graph of this because we only have one interaction between A and B, because other interaction BC and AC was removed. So this is the optimizing of operation condition. So this is the optimal condition that we achieved from RSM at 116 ppm, 1.6 bar and 3.7 acidity. We achieved 88% of rejection. When we run an actual application into the rejection of copper, we achieve 72.2% of rejection, which are 17.6 percentage error from the predicted data. Based on this data, we concluded that Jatropha is applicable for heavy metal rejection application. However, there are lots of unknowns still need to be explored, such as a mechanism of heavy metal rejection, whether the membrane form a complex structure with the heavy metal, or the rejection is mainly through filtration. So further testing, such as fouling testing, uh, could be done in order to verify the desirability and the reliability of Jatropha membrane for heavy metal rejection application. So that's all from me. Thank you.